Every single second, the entire internet is flooded with millions of new photos, audio tracks, and text documents. We generate, click, and share this data constantly, but we rarely look past the surface, ignoring the 3 or 4 letters sitting at the very end of every file name. If you do look at them, a question emerges. Why does a single photograph need so many different formats to exist? Why do we use JPG, PNG, WebP, and SVG to do what seems like the same job? The answer lies in the specific requirements of our hardware. A simple meme needs to load in milliseconds on a mobile network, while a raw, high-definition movie file contains enough data that it actually strains a hard drive to process it. Every extension is an engineered container designed for a specific trade-off. They are the result of a constant negotiation between human perception, storage capacity, and the limits of our processing power. To maximize storage, engineers created formats like MP3 and JPEG. These rely on lossy compression, a method that targets the specific limits of our own biology. This compares a standard audio track to an MP3. To shrink the file, the format permanently removes entire frequencies, specifically those above 16,000 Hz. Most human ears cannot detect those high frequencies. By deleting them, MP3 recovers what would be wasted space on your device. JPEG applies the same logic to images. It strips out tiny, granular pixel details that the human eye is unlikely to notice, allowing a high-resolution photo to take up a fraction of its original storage footprint. But because that data is deleted rather than hidden, the compromise is permanent. If you zoom into a JPEG, the image quickly breaks down into a blurry, pixelated grid because the foundational visual information no longer exists. Lossy formats prioritize the survival of the file. They sacrifice absolute digital accuracy so media can be shared on devices with limited capacity. In professional environments where every bit of data matters, these deletions are unacceptable. This is where lossless formats like LAV, FLAC, and PNG become the standard. A WAV file stores audio precisely in its original, uncompressed waveform. It keeps the recording in its purest state, which is why it remains the requirement for professional music production and sound design. PNG uses lossless compression to keep visual details sharp through multiple edits. It also provides a feature JPEGs cannot: transparency, allowing designers to layer logos and icons without an opaque background block. JPEG and PNG are raster formats made of static pixels, but an SVG is a vector, defined by geometric lines. Because it's a set of instructions, you can scale it infinitely. The math recalculates, so lines stay perfectly sharp regardless of resolution. Achieving this level of quality requires its own trade-off. You either deal with massive, uncompressed file sizes, or the complex mathematical rendering required to keep vectors smooth. When moving to video and documents, the choice shifts from quality to compatibility. You must decide if a file should be readable by everyone or optimized for specific hardware. This is why MP4 and DocX are global standards. The MP4 format uses the H.264 codec to balance decent visual quality with a file size small enough to play on any device. Similarly, DocX replaced the older Doc format to improve reliability. It was designed to be more resistant to corruption, allowing the software to recover data even after an unexpected system crash. Proprietary formats like Apple's MOV or M4A capture higher bit rates and sharper detail. They offer superior performance, but they are primarily designed to function within a specific ecosystem. Choosing a higher performance format often comes with a restriction. You trade universal compatibility for the elite performance of specialized hardware. Beyond media, there are meta formats. These files don't just hold content, they manipulate, organize, or control the system itself. Zip, RAR, and 7Z act as data compactors. They take large folders and shrink them into single encrypted packages, making it possible to transfer massive amounts of data over the web more efficiently. EXE, MSI, and APK files are different. These are executables, files containing specific code required by your hardware to execute a program or install new software directly onto your operating system. Because these files have the permission to run code and alter your system, they are the primary tools used to deploy malware. A single executable can be the vehicle that installs a Trojan horse or a keylogger alongside a legitimate program. Below the apps and photos we interact with is a foundational layer of the operating system that remains largely hidden from the user. Here, SYS files manage the bridge between software and your physical hardware, while DLL files provide a shared library of code that multiple different programs can use simultaneously to perform standard tasks like printing. Web formats like HTML and JavaScript work differently. These aren't stored on your drive. They are scripts living on a server that tell your browser how to structure and animate the websites you visit. Today, the internet is moving towards formats like WEBP and WEBM. These are engineered to replace older standards by prioritizing faster load times and lower data consumption for a web-first world. A file extension isn't just a label, it is a technical blueprint that reveals the specific choices made between quality, size, and the need to be understood by every device on the planet.